Okay, so I'm Amit, the senior maths faculty at the Nandyal Public School, and today the day of union. Today is the Union Day. We are going to discuss about how to take the union of the set, how to mix up the set, or how to extract out the common part of the set. That's the two major principle we are going to study today, right? So let me come on my screen. So today again I want to start my lecture by ask a question to you. There are two characters here as per you can see here. There is the first character which is girl, and if you will see the slide you can see that she is saying about her favorite subject. She is saying that she loves science, maths and English. And she is asking to another character which is boy, and she is saying that he is saying that he loves maths, science and maybe the Mapia. Now, my question is okay, you got it. You got the thing. There is a girl who loves science, math, and English. There is another boy who loves math, science, and this subject, whatever it is. Now, they're asking the question, which is you can see in the question number one, if they will combine all their favorite subject, what are they? That's the first question. If I will combine all the subjects which both like, which either he will like or that like, if I will combine all the subjects, then how many subjects I can list here? I can subject list up science, I can list up maths, I can list up English, I can list these three subjects which are coming from the girl character. But is any other subject which I can list up if I am listing all together? You can say I will list up maths again, science again, which is I think already list up. If I will talk about the sets, I don't think so I will list up them again. One more subject will come is this mapping. So when I am saying that if I want to list up all things together, what you are doing? You are listing up all the elements. I think I can use set language. In set language, I'm saying them elements. So I'm going to list up all elements which are either coming in this set or which are coming in that set. Or can I say, if you allow me, can I say I am doing the union of both the cases? Yeah, that's a mean. Union means collecting all the things together. So can I say I'm doing the union? I will use this word very soon. But that's how I'm going to do. What's my second question? Can you tell me the subject which both like? What are those? Yes, maths and science. So in this question, when I'm asking the subject which both like, what you are looking for? You are looking for the elements in set language. If I want to say, then I can say when I am asking the subject which both like, you are looking for the elements which are coming in both positions, which are coming in first set also, which are coming second set also. So in set theoretical language, I am going to say them as intersection. So that is my two big words which I am going to clear out in today's class. The taking the union of the sets and taking the intersection of the set. Just collab everything together or pick up only those elements which are coming in together, which are coming in those sets. Okay, let me give you one more example and then I will come on union. I hope you understood. But okay, the one more thing I designed for you in this. Now let's talk in terms of sets instead of talking in terms of other things. Here you can see the two pictures, the two collab of pictures. There is a one picture. I don't know these characters, but okay, in both pictures you can see some of the pictures of some of the characters. Maybe they are actor, journalist, or someone. I don't know. I personally don't know any one of them. Maybe you knows. But you can see both pictures. Let's see both as a set. You can see a set A, the set of some four persons, and there is a set B, the set of another four persons. Not another, there are some common also. You can even see that these are common. Right? Okay, just check out this picture. And now I'm going to ask the question. My question is, which of the following set shows the combination of set A and set B? I want to combine both set. I want to combine both picture. Once I will combine both picture, I have three options, and you need to tell me which one represents the combination. See, how can you combine both pictures? I hope you know what's the meaning of doing a combination. I think if I am doing the combination, I will collect all picture from my set A, I will collect all picture my set from my set B, and I will mix up all, and I will list up 4 and 4, total 8 pictures. And once I will list up total 8 pictures, I can say now photos are combined. Are you sure 8 pictures? Yeah, obviously 8 picture. If 4 picture in that side, 4 picture at that side, when I will combine, there would be total 8 pictures. But if you will see this picture set, picture number, the collab number A and collab number B, I think you can see the one picture is coming in both. Here is one the same pictures here as well as here. I don't think so. I will list up 8 different pictures because in set repetition is useless. When I'm making a collab, I don't want to repeat one picture 2 times. I just want to make a collab by combining it. How many pictures will come there? 7. I will not list the same picture 2 times. That's the meaning of doing the union of the set. When I said, when you are saying you did the mix of the two pictures, in set theoretical language, I can say I am doing the union of the two pictures, making something together. That's the meaning of union, right? There will be 7 pictures will come. The A would obviously a wrong answer because there is only 5 pictures are coming. That is impossible. In second, 1, 2, 3, 4, 5, 6, 7 pictures are coming. That could be possibility. In another one, only 6 pictures are coming. I think I'm not interested to check all, but I think this B is a correct answer. Are you understanding what's the meaning of combining things together? So, in set theoretical language, the same thing, when you are combining the things together, I am calling them to take the union, to take the union of the things together. So that's the meaning of taking union. So let me give you the example. Now I will talk in sets and I will give so many examples after that. But for example, I have the first set, which is the collection of, let's say, the first three elements, first three natural numbers, and my set B is, let's say, next three natural number 4, 5, 6. Can you tell me what set will come if I will combine both sets? If I will combine both sets, what set will come? Let me say the C. C is the combination of both sets. I'm saying C is the combination of both sets A and B. Then can you tell me what would be C? How many elements will come in set C? Obviously all elements of A, 1, 2 and 3, and then all elements of B, 4, okay, 4, 5 and 6. The sixth element will come in set C. So now I will not use this combination word actually. That is great word. When you are talking in English, it's a great word. But in maths, what I will say to this combination? Union. So this C, I can say, okay, let me come on again, one more sheet. Okay, let me remove them. I can say C is the union of set A and B. That's the meaning. I will not use combination but from now. I will use the union. Is it okay? Why the C is the set, the elements coming in A, the elements coming in B, and that's my set C, which is the union of set A and B. Did you understand that's what's the meaning? Let me give you a different example. I will give you almost 5 or 6 examples to clear out the union, but I hope it's easy. Let's say I have set A, which has 3 elements again, 1, 2 and 3, the first 3 natural numbers, and my set B is not next 3 natural number, but 3, 4 and 5. Now can I use direct union word? I'm not using combination word. I am saying, can you tell me the union of A and B? There is a way of representing A union B. I am finding the union of A and B, or In more better way, I can represent it by A, and for the union, I can represent big U sign and the B. That's the meaning. I am finding the union, the combination of A and B. Can you tell me what element will come here? I am just want to do combination. What are the elements coming in A? 1, 2, and 3. Now, what's element coming in B? 3, 4, and 5. So I will list 3 and 4 and 5 again because I'm combining all. But I already count 3. I already count 3 here. I will not count 3 again. So I will count 4 and 5. This is the union of my set A and set B. Or I can say that's the combination of both sets. So did you understand what's the meaning of collecting, of combining, or more better word, of taking union of the sets? The A union B. This is just a symbol. If I will come again, I am representing union by using this letter, but the U represent the union. And that's a major operation. How to take union. If you have a two sets, or more than two, I will come on more than two, but if you have a two set, and if you want to combine them, the best way of combining is taking union. And what's the meaning of union? List up all the elements which are either coming in A or which are coming in B. That's the meaning of taking union. Yes. Let me give you some more examples so that you can understand in a better way. Let's come on example number 1. I have a set A here, which is the collection of 4 elements, 3, 4, 5, and 6. And there is a set B here, which is collection of 4, 6, 8, and 10. And I want to find A union B. That's the symbol of A. Can you tell me what would be the A union B? I hope much easy. What you will do? You will list up all the elements which are either coming in A or which are either coming in B. But be careful, don't repeat one element 2 times. What are the elements coming in A? 3, 4, 5, and 6. When you are writing union, you can write down first set element very easily. But now when you will come on second set, when you will start to combine them, be careful and check it out whether you already count that element or not. Now in B, the next element which is coming is 4. By already count, but I already counted 4, so I don't need to count for that. But I don't want to do unnecessary repetition. I just want to combine them. The next element in B is coming 6, which I already counted here. So I will not count 6 again. What is the next element? 8. And you can see 8 is not here. So 8 will come here. Next is 10. 10 is not here. The next 10 will come here. That is my set, which is ready, which is representing A union B. The combination of A and B. The elements which are coming either in A or B. That's ready. That's the A union B. I hope you understood. Can I come on second example now? It's in something set builder form. I didn't cover up the set builder form till now. But okay, in upcoming lecture, I have a plan to give one video on set builder form also. Okay, I hope you know that. If you don't know, just wait for the video. But it's very easy to record it. It's a collection of all prime numbers less than 10. Can you tell me my set A? The all prime numbers less than 10. I hope you know what is prime number, which are coming in the itself table other than 1, which are only divisible by 1 and itself, God given prime numbers. So, can you tell me which are those numbers? Obviously, 2 is the smallest prime number, and then 3, they are just coming in their own tables other than 1, then 5, and then 7, and then, oh, not 9. That's all. These are the prime number less than 10. I need to stop at 10. Okay, now what is my set B? My set B is a collection of natural numbers, only the counting numbers, the factors of 12. Can you tell me the factors of 12? Factors of 12 which are divides 12. So I can say 2 is first factor. I'm talking about natural number. I can say 4 is the second factor. 3 is also a factor. 5 is not. 6 is another factor. And 12 is another factor. These are the factors of 12. 2, 4, 3, 6, 12. Even I can say 1 is also a factor. Yeah, 1 is the factor of everything. Now can you, what I want to find? I want to find the A union B. I want to combine them. Okay. So how you are going to combine? Can you tell me how you are going to combine? Yeah, the idea is you can write down your set A as usual, but when you will write down the set B, you need to take care that whether that element is already counted or not. Because I really don't want to count one element two times. No, I don't want to do this. Okay, I think you can do this. It's not much hard. Write down A 2 3 5 7, and then check one. One will come, two will not come, four will come, three will not come, six will come, 12 will come. That is your A. You can do that. Okay, let me do this. It's a 2 3 5 7. I'm writing A. Then 1 will come. 2 already came, so I will not write on again. 4 will come. 3 already came, so I will not write on again. 6 and 12 will come. That is A. That's okay. But I think if you will write down in different way, it could be more easy for you. Because what I said, when you are finding A union B, I said you can write down any one of the set, any of the one set without any problem. But when you will write down other sets, then you need to make sure that whether the element should not repeat. If you will see the set A and set B, I said you can write down the set A without any problem, and then when you will come on set B, you need to check it out. But I think set B is more larger. In set B, more elements are coming. 1, 2, 4, 3, 6, 12. Almost 6 elements are coming. In set A, only 4 elements are coming. So if you allow me, can I write down when I'm finding A union B, can I write down my B set first as it is? Because then I have less element to check. If I'm writing A, only 4 element 2, 3, 5, 7, then I need to do my checking for the remaining 6 elements, whether it's repeated or not. But if I will write down my big set first, 1, 2, 4, 3, 6, 12, then I need to do checking only for 4 elements, only for first 4 element, whether it's repeated or not. Here is a 2 which is already came, here is a 3 which is already came, here is a 5 not came, and the 7 not came. I just want to say both are same. This you can do in any order. Whenever you want to find the union, you can write down any first set, and when you will come on second set, then just start to count all of them, whether it's repeated or not. Or I can say, can I say this set as B union A? Because I took B set first, I wrote down as it is, and then I combine this. But doesn't matter. Both are equal. Doesn't matter because you are just combining them, so obviously both are equal. Actually, this is a very special property of union, and I hope you learned this property. The name of this property is commutativity. I hope you know commutativity. What's the meaning? It just means that you can combine them, you can take union in any order. Okay, forget the name, but just keep this thing in your mind. When you are combining the set, you can choose any of yours as a first set, and then you can start to combine. That is the commutativity, right? It's very famous property even in addition, not in subtraction, but in multiplication of numbers, and so many things where you can see the commutativity property, which holds in case of union. Okay, now I took for 2 sets. If you allow me, can I do the same experiment for the 3 sets? Let me write on my A set as 1, 2, 3. Let me write on my B set as, let's say, 3, 4, 5. And let me write on my C set as 4, 5, and 6. And what I want to do? I want to combine them all. I want to find A union B union C. I want to combine all of them. How can I do it? I know how to combine 2 sets. I can write on first set anyone, and then I will combine it by second set. But now there are 3 sets. How can I combine them? I think easy. And anyone can do this, but I think if I will write down what is my first set, 1, 2, 3, I want to combine them with 3, 4, 5, and then I want to combine them with set C, which is 4, 5, 6. How you will do this? It's easy. It's something you can say I can combine them first these two, and then whatever the output I can combine with second another one. That's something. What would be the combination of these two? Both are equal. Even I can change the order, but both elements are same. So I'm combining first one to first set only, and then 3 is coming here, which is already counted. I will not count 4 and 5. That's all. And then it's my first two combination done. Now I will combine it with third set. And now obviously which one is bigger? First one is bigger. So I will write on my first set as it is in the same order, and then I will combine them. Here is a 4 which is already counted, here is a 5 which is already here, only 6 will come. My A union B union C is ready. Yes, if I am taking the union of 3 sets, I will combine only 2 at a time first. If you are very good, you can go and combine all 3 ones at a time. But okay, the rule, according to rule, let's be slow. And it's telling you that if you have the 3 sets and you want to combine them, what you will do? You will not only first, you can combine any first, and you can combine any two, and then you can combine with third one. Or I can say you can combine first two, you can get the output, and then you can combine this that next set. Or maybe not like that, if you think like it would be beneficial for you to combine last two first, and then you can take the union with first one. Anything you can do, your answer would be same. I did the first one. If you want to perform the second one, combine B and C first and then do with A, you will get the same answer. And what's this property name? You learned the same property in case of numbers, but what's the property name? I think name is not that much important. Property is important, but name of the property where I can say you can move this parenthesis. You are taking two at a time, but you can take any two at a time in a God-given order. And the name of this property is associativity. So, so I can say that my union satisfying the associativity property also. It's associative, right? Okay. Now can I come on next one? Okay. Now I did discuss. Okay, let me give you one more example, and then we will discuss some other things. Let's come on this example. I have set A, which is the collection of all positive integers. That's my problem number 3. My set A is the collection of all positive integers. So what type of element is coming in my set A? All positive integers. I hope you know what are positive integers. 0 is not a positive integer, it's neutral. So I think all natural numbers. It's a set of all natural numbers. Am I right? This 3 dots representing it. Keep going on. The same pattern is forwarding. What is my set B? Set B is the set of all negative integers. What are the negative integers? All negative numbers. I can say -1, -2, -3, and so and so. And what they are calling for? They are asking for calculate the A union B. The rule is very simple. Write down any first. You can choose B, you can choose A. If you want to choose A, I can write down 1, 2, 3, and so and so. All positive numbers will come. Then start to add B. -1. Will -1 come here? No, it's all are negative. A contains all positive number. B contains all negative number. I don't think so anything will common here. So all elements will come here and so and so. There will be so many. All positive numbers will come in this set and all negative number will also come in this set. And that is my set which call as A union. The union of all. That's all. Can I give you one last problem just for fun? Can you tell me if I have set A, let's say 1, 2, 3, and I have set B, let's take empty set. I hope you know what's the meaning of empty sets. In last lecture we did this. Now my question is, can you tell me the answer of A union B, A union empty set, A union phi, what would be the answer? For the same principle, I can add any set first, but I think set A has three elements, set B has nothing. So obviously, I can write on my first set A 1, 2, 3 first, and now I will start to combine my second set. What second set has? Nothing. So I think my A union B would be same set back. Yeah. So I can say my set A, if I have any set A, and if I will do say union of that set with my empty set, then always I will get the same answer back because you will list up A set first and then you have nothing to combine with A, so you will get the same answer back. Yeah, and that is A union phi is A. It's okay? Okay, that's all. Actually, one more thing I want to insert here. In numbers also, or I can say in addition also, there is a number here. If you will add that number with any other number, you will get the same answer. For example, if I have a number 2, what should I add in 2 so that you will get back to 0? 2 plus 0 is 2. 3 plus 0 is 2. 0 is a number which you will add in any number, you are getting the same answer. That's why, and I think 0 is only number which going like that. That's why I think when you were in 6th standard and 7th standard, when you were in school, the preschool, you gave a special name to 0. Do you remember what that special name? It's not much mandatory to memorize this, but if someone remember, I said 0 as an additive identity. It's like just because it's a special number, and it's adding in anything but not giving any change. Are you seeing the same thing the phi has? Phi is going and taking union with any set, but it will not change anyone. It will not change the set. So that's why maybe in some of the book they may say phi as an identity set, not identity but as an identity, because phi will involve in the union but will not change anything anytime. That's the meaning of this set. Okay, that's all about to take the union. That's all. I hope you understood what's the meaning of taking union just to combine the sets. Okay, now can I come on my second piece of lecture? My first piece of the lecture complete. To combine the sets. Now let me come on my second piece of the lecture, which is based on my second question. Do you remember when I start this lecture I asked, not I, they asked the questions. Two questions, they asked the two questions from each other. First question is what is the combination of all subject, which leads to the union, which I already done. What was their second question? What are the subjects that both like? The girl was like the science, math, and English. Boy was like the math, science, and mappy. Which subject they like both? Science and maths, right? Science and math they also like, and science and math they also like, right? In the set theory, I have another name for this, and what's that name? Intersection. So let me come here and let me ask the same thing. The intersection of set where I am just combining the set. Let me give you more example. For example, if I have a set A which is contain 1, 2 and 3, and I have a set B which contain 3, 4 and 5, can you tell me what I'm asking for? The elements which are coming in both. Like in previous question, the books, the subject which like both. So element which are coming in both. Can you tell me the elements? The first set contains 1, 2, 3. The second sentence contains 3. Is 3 coming here? Yeah, 3 is coming here. 3 is the first element which is coming here. The next element is 4. Is 4 coming in set A? No. Is 5? Is the next element is 5 coming in set A? No. So what are the elements which are coming in both sets? Only 3. So this is only element, or this is the set of all the common elements, I can say. And what's the mathematical name for that? This is the intersection of set A, okay, sorry, set A and set B. This is the intersection of both sets. the intersection of set A and set B, right? And let me allot a symbol also for it. If this is my set A, this is my set B, and intersection of set A, B is 3, can I give the symbol? For union, I give the U symbol. For intersection, I am going to give inverted U, just like the opposite of U. This set is A intersection B. I will pronounce as A intersection B, which is 3. Right? Did you understand what's the meaning of intersection? Collecting of those elements which are common or which are coming in both. That's the meaning of intersection. Right? Okay. Let me just share some problems with you so that you will get through by intersection also, and it will also become easy for you. My set A is 1, 3, 5, 7, 9. My set B is 2, 3, 5, 7, 11, and 30. And I want to do the intersection. What's the meaning of intersection? I want to collect up those elements which are coming in both. How can you do this? It's much easy. Pick up any set and try to check it out. Go with one by one. Here is a 2. Check it out whether 2 is coming there. You will find 2 in another set also. Count that in intersection. Right? So here the 2 is coming. Here 2 is not coming. The 2 is not a common element. Here 3 is coming. Here 3 is coming. 3 is first common element. Here 5 is coming. Here also 5 is coming. 5 is the next element. Here 7 is coming. Here also 7 is coming. 7 is the next element. Here 11 is coming. Here 11 is missing. That's not common element. Here is 13. Here is not 13. So what is my intersection of 7? 3, 5, 7. That's the intersection. Again, I want to ask this question. If you want to do the intersection, then which set you should pick up first? From which set you need to start to match the elements, which contain less elements. That is not the one you can do in any order. I pick up set B and I start to count 2 here and I try to find 2 here. But how many elements it has? 6. And how many elements it has? 5. So instead of going in that order, if I will choose A and if I will start to find here, or if I will find in reverse order, B intersection A, here is 1 is coming, if 1 is not here, here is 3 is coming, here 3 is here 5 is coming, 5 is here 7 is coming, 7 is here is 9 is here 9 is not here. So you can do in any order, either pick up first set and try to find in second, or either pick up second set and try to find in first. You can do anything, both are equal, and you can choose anything, but smart choice is where is the less element, try to pick up from there and try to find in the biggest set. Anyone, but I want to say that the A intersection B and the B intersection A would be equal as union. In case of union also it was equal, and I can say in math language, in more technical language, I can say the intersection satisfy the commutativity property. Is it okay? It satisfies the commutativity property. Can I come on my second problem now? Okay, my second problem is the set A, which contains all the natural number which are factor of 12. I took the same example in case of my union also. The factors are 1, 2, 3, 4, 6 and 12. What is my set B? The set B is the factors of 18. Natural factors of 18. What are the factors of 18? 1, 2 is the factor of 18, 2 divides 18, 3 divides 18, 4, 4 is not, 6 divides 18, 9 divides 18, and 18 divides 18. These are the set B. And what I am looking for? A intersection B. And as per I say, you can choose any one. But I will choose where the elements are less. And I can see set A has less element, and I will try to match up whether it's coming on B or not. 1 is here, 1 is here, the 1 is first. 2 is also coming in both. 3 is also coming in both. 4 is missing here, it's not common. 6 is coming in both, and 12 is not. So my A intersection B would be just set 1, 2, 3, 6. That's all. Yes? Okay. Can I give you one more set? My set A is contain only two elements, the first two multiples of 2, 2 and 4. And my set B contain, let's say, these much elements. And I want to find A intersection B. Tell. Yeah, 2 is on the answer. But I gave you this example just because now don't choose set B and don't try to match from set A. Don't find B intersection A. Even answer would be same. But here you need to pick up 2. You need to check 2 is here. Here is a 4. 4 is not here. You can be quick. That's how somewhere the commutative property could be helpful. If the elements are the difference of elements is very high, then this property could be helpful. That's all. Now, if you allow me, can I give you the example of three sets now? My set A is, let's say, 1, 2, 3. My set B is, let's say, 3, 4, 5. My set C is, let's say, 5, 6, 7. And I want to find the intersection of A intersection B and C. What's the meaning? I want to find out the elements which are common in all. How can I do this? But I told you at the time of union. Take two at a time first. You can choose any two in the God given order. Take two at a time, find common, and then go with the next one. Right? So here is a intersection B. Here is a intersection B. What is common? Is one here, one is not here. Two is here, two is not here. Three and three. Only three is common. That is my answer of A intersection B. Now the intersection with what? With C. 5, 6, 7. Now can you tell me what is common in both? 3 and 5, 6, 7? Nothing. So what is the answer? Empty set. There is nothing common. So I can say in symbol, the answer is empty set. Yeah, that's all. I did with that also. Or maybe I already told you, doesn't matter you are selecting first two, even you can select next two and you can do in this order and you can tell both are equal. In a God given order, you can do this thing, their answer will be same. Or I can say intersection also satisfy the associative property. That's all. Yes. Okay. Now let's come on example 7. Okay. So sorry for a small break. Now I think we are ready. Okay, so I was in the example number 7 and let's go. Here is a set A, and what this set A? It's a collection of all multiples of 3. But here n is integer, so I can say it's a collection of all multiples of 3 which are integer. So can you give me the set A? What would be the set A? It's not only the positive integer, even the negative integers included here. So I can say in positive 0, 3, 6, 9, all positive integers, and then all negative integers also. I can say minus 3, minus 6, minus 9, and so and so. This is my huge set. Somewhere I can say subset of my integer, where only all integers which are multiple of 3 is come. I think my set A is ready. Now, can you tell me the set B of me? What is the set B? Collection of all elements which are collection of all integers which are multiple of 4. Can you tell me what type of element will come here? 0, all positive multiples 4, 8, 12 and so. And I can say all negative multiples also minus 4, minus 8, minus 12 and so and so and so. And what they are asking for? They are asking for A intersection B. I'm coming down. Okay. So now here both sets are very huge. How can you find out the intersection? How can you find out the common element? Okay, come on set A, come on set B. You can take any set. Can I start from at least 0? I think 0 is the first common element which you can see here. So can I pick up 0 first? I'm writing 0 in between because I know something will come that side also and something will come that side also. Okay. Now tell me what is the first element after 0 you will see common in both sets. The first set is going on by the multiples of 3. The second set is going on by the multiple of 4. What will come in both sets? What is the first element which will come in both sets? If I will pick up the table of, let's say, 3, 3 will not come. I'm reading the table of 3 and I will check it out what will come in the table of 4 also. That's the meaning of common element. Which are coming here also, which are coming here also. What is the meaning? You are looking for element which are coming in the multiples of 3 and which are coming in the multiples of 4 also. Means you are looking for a number which are multiple of 3 as well as 4. Obviously 3 is not the number. Is 6 is a multiple of 3 as well as 4 both? No. 9? No. What is the next? 12. Yeah, 12 is the first number after 0 in positive, which is a multiple of 3 also, which is multiple of 4 also. So I think 12 would be the first common element which will come in those set. What's next? Can you guess the next one? Which would be multiple of 3 as well as 4? Let me write down. What will come after 12? 15. Is 15 multiple of 4? No. Next one is 18. Is 18 is a multiple of 3 obviously, but is it a multiple of 4? No. Next is 21, which is also not. Next is 24. Yes. 24 is the next multiple of 3 as well as 4. Now can you guess the next one? Are you seeing any pattern? The first number is 0, which is multiple of 3 and 4. Second is 12, which is multiple of 3 and 4. Third is 24, which is the multiple of 3 and 4. Are you seeing that? If you are looking for a number which is multiple of 3 as well as 4, means what you are looking for? Multiples of 12. The next number would be 36 and so and so. And similarly negative, negative 12, negative 24 and so and so. That is my A intersection B. If you want to represent in a set builder form, in the same way you can write down the collection of all x such that x is a multiple of 12 where n is integers. That's all. I hope it's clear. Right? Okay. Now can I come on example number 8 if you allow me? I'm doing example number 8 first, then I will come on 9. That is the next problem. The last second problem where I want to talk about intervals. So okay, before I will come on this example, let me tell you what's the meaning of this number. Okay, I want a blank sheet. In the example number 8, if you will see that they are using some brackets. Maybe they are using this bracket. What's the meaning of this bracket 2, 4? What this represents? I think when I was in the last class, I told you that if your set A contains a 3 element, then how many subsets you can make? And I hope you remember it was 2 power 3 and I even proved it. Now, when I came in case of real numbers, I said real numbers is so many, you don't know how many, then how many subsets you can create? 2 is the power of so many, and which is non-defined. But I told you, you cannot say 2 power infinity, but you can say the subsets will be so many. And I promise you there that I will come on intervals. I will come on some, there are so many, I cannot say how many, there will be infinite many, but okay, but there would be some famous subsets of the real number which I want to represent and which is called intervals. That is something I want to discuss here. What is thing is just like in a big movie, you can say interval is a very short part, interval of a big movie. Same, real numbers are so many, but I can create some small intervals in a big set, and in which 2, 4 is a such interval. We are saying it's an open interval. The name for this is open interval. The open interval means when you are writing the two real numbers and you are putting open bracket, it means you are creating a set of all real numbers coming in between 2 to 4. That's called. And obviously, it's a subset of real number. It's not all real number I'm covering it. Then I'm covering a small interval, or only those real number which are coming in that small interval in between 2 and 4. And I'm pronouncing it's an open interval of 2 and 4. It's all real number coming exactly in between 2 and 4. Not even 2, not even 4, but coming in between 2. That's the first famous interval which is famous as a subset of real. Can I tell you another one? There is a one more interval which I am using, where instead of using open interval, I am using closed interval. That is called closed interval. And what this closed interval about? In case of big real number, closed interval telling you collection of all such real numbers coming between 2 and 4. But now even 2 and 4, the endpoints you can include now. That's the meaning of closed interval. And these two are the very famous intervals or the subsets of the real numbers. When you are using open brackets, you are calling it open interval. All numbers coming in between 2 and 4, but 2 and 4 are not allowed. When you are using this big bracket of close or close bracket, still you are counting all real number coming between 2 and 4, but now 2 and 4, this endpoint will also come in this set. I hope you understood what's the meaning. What's the meaning of 3 and 5? Open interval 3 and 5. The subset of real number coming in between what? Exactly 3 and 5. The collection of all real numbers coming exactly in between, not equal, sorry, 3 and 5. Right? Can you tell me what's the meaning? Sorry. Can you tell me what's the meaning of close interval 7, 8? Obviously, all real numbers coming in between 7 and 8, but 7 and 8 is also allowed. All real number, including my AND digit 7 and 8. Yes? Let me ask last question, then I will come on my example number 7. Tell me what's the meaning of open interval 7 but close interval at 8. What's the meaning? Yeah, it means collection of all real number coming between 7 and 8. But will 7 be allowed? No, because it's an open interval. Open means not allowed. It's open. Will 8 be allowed? Yes, because it's a closed interval are coming. You can say collection of all interval coming between 7 and 8, collection of all real numbers coming in between 7 and 8. But your 7 will not be there, but 8 would be there. That's the meaning. You can say like a semi-open, semi-closed. That's something. Okay. Now I think I'm ready to do the example number 11. Here is my set A, open interval 2 and 4. What's the meaning? Collection of all real numbers coming in between what? Coming in between 2 and 4. Now my set B is a collection of all real numbers coming in between what? Coming in between 3 and 5. But because it's not a complete open, it's not a complete close, it's a semi-close, semi-open. Will 3 be allowed? Yes. Will 5 be allowed? No. That's my two cents. And now what I am looking for? A intersection B. Can you tell me what will be the A intersection B? What's A? A is all real number coming between 2 and 4. B is all real number coming in between 3 and 5. What is common? Are you seeing this? If I will try to draw it, if you cannot see, I will try to draw something here. If you, I can say this is my real line. Let's say this is my 2, this is my 4. Then what is my set A? All real number coming between 2 and 4. What is set B? All real number coming, here is a 3, 5 would be after 4. And what is my set B? Coming, all real number coming between 3 and 5. But when you are talking about set A, all real number coming between 2 and 4, but 2 is not coming, 4 is not coming. I am using an open circle. It means 2 and 4 I cannot take. What's the meaning of this? Here 3 is allowed. Can I make a bold circle here? But 5 is not allowed. And all real number coming between 3 and 5 is allowed. Now, can you tell me what is the common elements which are coming in both? Can you tell me the common reason or the common element which are coming in both? The first set is all real number from 2 to 4. Second set all real number from 3 to 5, including 3. Where both squares are coming, both rectangles are coming. All real number in between 3 and 4. You can see that all in this portion coming in first set also, and this portion coming in my second set also. So what will be my intersection be? All real numbers coming between 3 and 4. Now tell me, is 3 allowed? 3 is coming in my first set, 3 is coming in my second set. Even you can see bold letter here. 3 is allowed, but is 4 allowed? No, 4 is not coming in first set. So you can say, if I want to write down in terms of interval, what can I write down? All elements coming between 3 and 4. But where I should use open bracket, where should I use close bracket? The first endpoint is allowed, so I will use close bracket here. But 4 is not allowed, I will use open bracket here. That's my intersection. The intersection of 2, 4, intersection of 3, 5 would be what? 3, 4. That's the answer. Is it? Okay. Now the last one, not the least, the example number 9. There are first set contains 5 element 1, 3, 5, 7, 9. First 5 odd number. Second set contain 4 element 2, 4, 6, 8. Third element contain 5 element. They are asking for A intersection B. That is something I hope you is now ready to do this by your own. That is something is your homework. Please do it by your own. And that's all about the intersection. Okay. So in the today's lecture, I told you about particularly two things. If you have a two set or not two set, if you have any number of set, you can combine them and you can use the operation union, or you can choose to take only common element and you can call them intersection. These are the two major operation, union and intersection, and that is much important. Am I right? Now, can I mix up union and intersection together? And can I ask you the questions? Okay, let's come on screen and I am going to do the same thing. Now, I am giving you three sets. My first set is 1, 2, 3. My second set is 3, 4, 5. And my third set is, let's say, 5, 6, and 7. Now I am going to make an expression where I am going to add union and intersection all at a time. I want to find, let's say, A union B intersection C. That's all. Oh, let me not use bracket. I want to find A union B intersection C. Union and intersection all at a time. Now how will you do? The same thing. Whenever you have more than two sets, I don't think so you are doing all three sets or more than three sets at a time. What are you doing? Two at a time. So here, if I want to solve A union B intersection C, you will solve B intersection C first. Let me do it. A set I'm writing as it is 1, 2, 3. Union. Now B intersection C. What's the meaning of B intersection C? The elements common in both. Here is a B, 3 is coming, 3 is not coming in my next set C. Here is 4 is coming, 4 is not coming in my next set. Here is 5 is coming, 5 is coming here. B intersection C is found. Now I got B intersection C. Now you want to find A union of B intersection C, union of both. What is answer? 1, 2, 3. The big set you can write as it is, and then next set you can write down. By seeing that no repetition is allowed, my final answer of A union B intersection C would be 1, 2, 3, 5. That's all. Okay, that's all. Can I tell you one alternative way to solve this? I have one more alternative way in my mind. And in case of numbers, you said this property as distributive property. I don't know whether you know that or not, but the same question you can do. You already you get the answer, but you can do in another way. Instead of solving A union B intersection C, I can distribute this union sign inside, and I can say that that would be equal to A union B and the same intersection sign and A union C. If you will do that also, still you will get the same answer. It's same like if you have a 2 multiply 3 plus 5. Either you can go in same order, add 5, 3 and do the 2 times, or multiply 2 inside and say 2 times of 3, same sign, this one plus and 2 times 5. Same thing, if you have a 2 sign union and intersection, you can distribute this union sign and the property name is distributive. That is also you need to keep in, not property name, but keep this thing in your mind, that how you can change the parenthesis, how you can move this union sign with B and C by keeping the same in between sign. Now let me show you the same. What will be A union B? Can I write down directly if you allow me? My set A is 1 2 3, my set is B 3 4 5. What will be A union B? 1 2 3, 3 already here, 4 5. Now A union C. What is A union C? 1 2 3 as it is, and C is 5 6 7, nothing common. I can write down as it is. Now tell me what's intersection. This set is small, this set is big. Can I pick up my small set? One is here, one is here, one will come here. Two is here, two is here, two is going to become here. Three is also common, both coming in both. Four, no. Five, yes. And you can see both are same. Yeah, I just want to say that if you have the two signs together, if you have two signs together, A union of B intersection C, either follow the parenthesis as it is, or if you can distribute this union sign inside and you can join it with B and with C, and you can write on A union B, you can calculate A union C, and then whatever the sign is here, you will put here. Yeah, or maybe I can see in another way, instead of union, if intersection is above and union is inside, then also you can do the same sign. This sign you can join with B and C. You can join it with B, you can join it with C, and what will sign will come in between? The union. That's all. Okay. That's I think I can share to you about union and intersection. I think that's all for you today. I have one more thing which I want to discuss is how to make the Venn diagram, how to represent this pictorially. I will come on this later. So that's all for today. And I think that's all. Thank you so much for joining me today and have a nice day.